Alright, you guys, so here's what we're going to do. What we're going to do is revisit the idea that we can actually find exact values for special angles, right? 30, 45, and 60. Now, we've already done that in quad 1, but we now know that these guys can serve as reference angles in quad 2, quad 3, and quad 4. And so since they serve as reference angles, that means all that information we did in quad 1 now applies in quad number 3, 2, 3, and 4. And that also now means that we can find sines and cosines, tangents, secants, all that other good stuff, right, for these angles. And that's basically what we're going to do. What I also hope I'm going to do is show you, again, homework-wise, everything you should be showing to back up your story, all right, and go of that nature. So, first round, we're going to find the sine, cosine, and tangent of 135 degrees. What is their exact value? All right, and so we'd like to go back to our right triangle situation. So picture-wise, right, what we have for 135 is something like this, right? So there's 135 degrees. What's the corresponding reference angle for that? Well, if you keep rotating, or if you use the formula, I'll go ahead and use the formula here. It's 180 minus 135. My reference angle right there is 45 degrees. Alright, so 45 degrees in there. The representative right triangle, what do I have? Well, since it's 45, right, this will be a -1 distance because it's negative. Y will be a +1 because we're positive. And then I think if you remember our 45, 45, 90, right, the hypotenuse will always be the square root of 2. So for this reference angle right here, right, here's the adjacent, it's -1. Here's the opposite, it's +1, and there's the hypotenuse. And now we're ready to go because by theory, right, the sine of 135 is the same as this 45 degree reference. All right, and again, here's the picture to show me. So what we have then for this picture is we know that a sine is the opposite over the hypotenuse. And for this picture that I've drawn, the opposite is 1 and the hypotenuse is the square root of 2. And rationalizing my denominator, we get square root of 2 over 2. So the sine of 135, right, is the square root of 2 over 2 using that reference angle definition, using that reference angle right triangle situation in conjunction with our right triangle definition. We can even do cosine of 135. Again, this would be the same as the cosine of that 45 degree reference that we just drew, right? And so again, by definition, cosine is the adjacent over the hypotenuse. So for my picture, for this reference angle, the adjacent is -1 and the hypotenuse is the square root of 2. And again, rationalizing my denominator, we get negative square roots of 2, right? So this is negative square roots of 2 over 2. So we now have the exact value of the cosine of 135. And I think, again, if you go back, these actually were equal, but cosine of 45 is actually positive square root of 2 over 2. But I have that in red. I'm talking about the reference angle, and this picture is what's making them equal. Not that they're actually literally equal. That would be insane. One's positive, one's negative. So again, picture behind what I'm saying is very important. This tangent of 135, again, by theory, we're saying it's the same as the tangent of that 45 degree reference. Alrighty? And so for this picture, right, we have the tangent is the opposite over the adjacent, right? That's our new definition. For this picture, for this 45 degree reference, we have an opposite of 1 and an adjacent of -1. So the tangent of 135 would be equal to -1. And of course we can find the others, cosecant and secant and cotangent, by using their definitions or just using reciprocals here. Okay, so that is how we use, right, a reference angle and its corresponding right triangle to help me find values, in this case, of some sines and cosines and tangent values of some special angles. All right, so moving along, let me do one more round and then I'll cut and we'll do another video. So this time, this next round, we're talking about 210. So my picture now, right, 210 takes us around to about right there. All right, so there's 210 degrees. So I can see there's a reference angle here, right, and it's corresponding right triangles. So let's see what we've got, right? What is the reference angle? Well, using the little formula, right, it's basically the angle, which is 210 minus 180. So we have a 30-degree reference. And so this means, again, this ratio would be -1, this would be 2, and this would be negative square roots of 3. So I'm labeling my 30, 60, 90, right? The one opposite basically determines everybody else. But because I'm in quad number 3, right, my y value is -1, my x value is -3, and my hypotenuse is always going to be positive. So there you have it. So here's my hypotenuse, here's my opposite, and here's my adjacent. And so we're ready to go. So the sine of 210, right, would be the same as the sine of this 30-degree reference that I drew. Right, that's really important. By definition, sine is the opposite over the hypotenuse, and in this case, my opposite is -1. My hypotenuse is 2. So the exact value of the sine of 210 is -1/2. The cosine, again, what we have is we know that the cosine of 210 is the same as the cosine of my reference angle for that picture. All right, and so by definition, it's the adjacent over the hypotenuse. And in this situation, my adjacent is negative square root of 3, and the hypotenuse is 2. So the cosine of 210 is negative square root of 3 over 2. All right, there's its exact value. Tangent of 210, well, again, by using our theory that we talked about, the tangent to 210 would be the same as the tangent of the reference angle for this picture. And for this reference angle, the opposite over the adjacent, right, is -1 over square root of -3. And rationalizing my denominator, we get the square root of 3 over 3. Negative divided by negative is a positive. So that guy is the square root of 3 over 3, and that's a positive. That's just part of my guy there. So that is how I use a reference angle in conjunction with our right triangle knowledge of 30, 45, 60-degree right triangles. We're almost 8 minutes into this, and I got 8 more problems to do. So how about I pause, and we'll just go to a new video and look at 300, and then these other little crazy 390 and 585 and 480. But again, please, as you saw as I did that, anything you answer, right, should be a picture behind it. So if you have the picture behind it and you show your work, I should be able to follow you along and you'll get full credit. See you in the next video.